Let's move to another transformation method, that is horizontally stretching and shrinking of graphs. When we multiply a function's input by a positive constant, we get a function whose graph is stretched or compressed horizontally in relation to the graph of the original function. When the constant is greater than 1, the graph is shrunk horizontally towards the y-axis. And when the constant is in between 0 and 1, the graph is stretched horizontally away from y-axis. Let f be a function and c a positive real number, horizontally shrinking. If c is greater than 1, the graph of y equals f of x is horizontally shrunk by the graph of y equals f of cx. The graph of y equals f of c times x, dividing each of its x coordinates by c. Next, horizontally stretching. If this constant is in between 0 and 1, the graph of y equals f of x is horizontally stretched by the graph of y equals f of c times x, dividing each of its x coordinates by c. Since c is in between 0 and 1, dividing by c will be as same as multiplying by the reciprocal of c. Let's move to a simple example. Use the graph of f of x is equals to absolute value of x to obtain g of x is equals to absolute value of 2 times x. So as you can see, our main graph is always absolute value of x, and then using this we have to obtain g of x, which is equals to absolute value of 2 times x. Here, as you can see, c is greater than 1. So this has the this is a horizontal shrink. The graph will be shrunk horizontally towards the y-axis by by 2 units. So you can see that the x values have changed from 2 to 1, which means the original x value, the x value of the original x coordinate or of the original function has been divided by 2, which is equals to the constant in gx in the horizontally shrunk graph, which is g of x is equals to absolute value of 2 times x. And let's move to h of x is equals to absolute value of half times x. Here c is in between 0 and 1. So the graph is stretched horizontally away from y-axis. As you can see, if the constant is greater than 1, then it is shrunk horizontally towards the y-axis, and when the constant is in between 0 and 1, the graph is stretched horizontally away from y-axis. And in the case of h of x, you can see that the x-axis, the x-coordinate value has been multiplied by by 2. So which means this is equivalent to so it is stretched horizontally towards y-axis. Then what we are going to do is graphing using a sequence of transformations. As you can see, in this example, we are trying to use a simple function, and then using that we are going to derive h of x, which is negative square root half times x minus 1 plus 2, which is a complex function. First of all, what we have to do is we have to sketch f of x is equals to square root of x. After that, what we're going to do is we vertically shift 2 units upwards the given f of x, which is in red. Then we horizontally stretch that graph by 2, because we have half in front of x minus 1, and then we are going to reflect across x-axis because we have negative sign in front of our f of x, and finally we are going to shift 1 unit to the right. This is how we obtain a complex function using a simple common graph that we know.